Okay, are we streaming? It looks like we are. Yeah. We're on, we're live, it's me, it's Bladez. And yes, we're going to have some fun today. Let's have a look. What do we need to have fun? Well, I don't need that on screen. That'll do. That'll do. I'm happy. Alrighty, so Sandbox for C, OpenGL. Lovely. What can we do with a black box on a red background? You'd be surprised. First of all, let's get set up here with a microphone and a keyboard and everything. Right, there's a keyboard. Microphone, come over here. Thank you. Thank you, thank you, thank you. Oh, lovely. What can we do? What can we do? What can we do? Oh, that was it. We're doing shaders today, aren't we? Because that's a black box. I want it colourful. I would like a colourful box. Yeah. Let's have a colourful box. Where are we up to in our notes? Let's make a shader. Oh, good. I've also got a to-do. Fix memory leak on GFX card. Yes, we have a memory leak. Nobody noticed it because, well, our program's a little bit small. To facilitate that, I was messing around with vectors. And we'll talk about that a little bit now, I guess. Vectors are C++, the vector class, which basically is an array which you can expand. It doesn't have a fixed size. Unfortunately, C doesn't have that kind of implementation. But as you can see here, I've got a vector, not a class, but a series of functions, we'll call them. And if we run our program now, thank you, close the window. As you can see, what I've done is I've added the numbers 0 to 9 to the vector, gives it a size of 10. Capacity of the vector is 16. It's true that it's not empty, and it works. So my little test works. So that's the end of that test. Copy that. No, cut that. I'm going to pop that in the vector class. So it's in sand core vector h. What I'll do is I'll pop it here. And then all I have to do is move that. To there. Fantastic. So there's my example. Lovely. So that's my vector class sorted out. Lovely. Don't need to do anything else with that. We can get this back to some kind of normality. And we can get on with shaders. So yeah, we've got this cleanup question mark here. That's what I'm talking about. We need to do a cleanup. So main function looks something like this. Massive, isn't it? I know. Everything else looks okay. Shaders, get on with it. let's get on with it. Resource, GLSL, new file. I'm going to call this the color shader. Because that's what it's going to be. And we will have a .vs for vertex shader. Really? Really? Okay, shade language support. There we go. We've got it now. That's very kind of them. Not that I ultimately care. But, yeah. Why am I still not saved on here? Thank you. Let's go back. Being distracted. GLSL will need 2 files. We're only going to be dealing, to start off with anyway, with vertex and fragment shaders. So fragment shader. There we go. Color shader and a fragment shader. So let's start off with the vertex shader and just get on with it. We have to tell our graphics, the graphics card is going to run this, by the way. This is a program that gets run on your graphics card. That's what a shader is. That's all it is. The compute shader and the geometry shader I'm also interested in. I've been looking at compute shaders recently and they do look interesting. Thousands of calculations all being calculated in line, so asynchronously. Amazing stuff, amazing speed, put it that way. So let's tell our graphics card which version of OpenGL I want. So that's 3.3. Core, please. There we go, that's looking good. And that means I've now got to use 3.3 OpenGL language, which is slightly different from other variations. And I know that 4.6 is definitely different to this one. So if you are using a different OpenGL shader version than me, then that's fine. Just be aware that the commands I use probably won't work for you. So there you go. Layout. The reason I like 3.3 is because it's got this thing in it. Location. And I'm going to set the first location to 0. And we're going to bring in a vec4. And it's going to be positions. The vertex positions. Layout. And that's going to be location 1. Remember, I couldn't do colour before because the graphics card didn't know what to do with it. And I certainly wasn't going to tell it. Vec4, and we're going to say colour. Don't pluralise. Those are the only 2 things we've got at the moment, isn't it? We've got an index, but that doesn't matter here. Right, no, I'm not going to do any more than that. I just want to get colour going first. So it's a bit like C. It is like C, because that's where this language is taken from. So it's void main. We haven't seen that anywhere before, have we? I'm going to set the colour as a pass-through. And we are in the vertex shader. So vertex colour. I just prefix it. You don't have to. I just put V underscore if I'm in the vertex shader. And we'll call that colour. Do need a semicolon at the end of these. It is C after all. Out V Yeah, vec4, and it's going to be v underscore color. So that's what we're sending out to the fragment shader. But our positions can stay here. So GL underscore position deprecated, no longer available in anything beyond 3.3. This is the last time you can use this variable. So you would need an out of V position, or whatever you want to call it, if you're in a shader that doesn't have GL position. Position. And all we're going to do is set that equal to position. There you go. Difficult? No, not difficult. That's the shader. Done. All we have to do is make sure that this, or anything that we send out to the fragment shader, agrees on the fragment shader side. So we copy that over. And it's coming in. The position goes off to one of the, well, it gets held for the position of the pixel. So that goes to your graphics card. So that is a graphics card thingy storage area where it stores positions. The colour shader's finished. That's it. That's all I'm doing for now. Very, very simple. But don't forget the last line, it's important. Save. So again, hash version. Very first line every time. 330 call. Void main. Yes, this one has a main too. We're only taking in the colour, so all I'm going to say here is f underscore colour, because I'm in the fragment shader, equals v underscore colour. There's a problem though there, because we need to send that out, don't we? I wonder if I could use GL colour. It's 330, I think I can. So what we would normally do is something like out vec4 f underscore colour. What I'm going to try and do instead is see if I can use GL. So it would be GL underscore colour. I think. We'll soon find out if it works or not, won't we? I've got coffee. Right, so there's two shaders written. Massive question mark on the fragment shader. So I don't really think I should do that. No, I'm not going to. My memory's telling me don't do it. And we just send that out to the next wherever it goes to. Out. Vec4 v underscore colour. Right, so it knows it's vec4. Just to make sure. I just don't know if that's really required. Doesn't look wrong to me. So anyway, back to the sandbox. Right, where would we like to create our shader? Run window. Here's run. So we want to create our shader here. Yeah. We're drawing the elements here. Yeah, okay. So what we're going to need is a GL shader program. Why am I not getting one? Interesting. Okay, fine. Let's lock it up. Let's at least have some kind of reference to go off for my OpenGL commands, which I do not know instinctively, and I'm not looking them all up. I only want a certain few. So, archive. Vectorlib, yeah, brilliant stuff. I did download it. I got it off GitHub. Fantastic. Fantastic stuff. And then I've modified it all to fit our needs, as it were. Okay. Render engine, maybe. Let's just have a look what I did in the basic shader here. I haven't looked at this, so... I don't even send it out. So that's wrong. there's a wrong shader to be looking at. Yeah, I don't send it out. I just put color equals lighting and then that's it. That's dangerous. That's interesting. I would not say that that shader is correct. We don't send it out though. God knows how those shaders were working. Alright. Fair enough. Let's have a look at the API. That's data loader. La 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 la. So, data loader. Yeah. Create VAOs. That's all VAOs. What? We didn't have a shader? We might need that. No, we don't. Interesting. No shader loading. Those are just draws. Draw calls. Ah! It's the shader foundation that I'm interested in. Not the static shader or the terrain shader. This is C++ version of GL create program. So what is a shader program? You know all about all of that, like, yeah. Create shader, here we go. GL create shader, shader type. It's just a glue in. Wow. I'll keep that then, because that's good reference. Okay, we've got a reference manual. So it's a GL uint. We'll call it shader, I suppose. We'll call it color shader. Color shader equals suppose load shader. Just realised something. Oh no, I have done it. Make sure I've done it or not. Yeah, I have. Capitals. Okay, good. And we want to pass in resources. RESOUR. Will this work? Resources. I don't know. GLSL. Let's find out. Color shader. Actually, no. Let's do it that way. Right, we don't have a function called load shader. So I guess we're going to have to make one. Well, that's what I want. Where should we make it? This is all test data, isn't it? Alright, we'll make it here then. Above the test data. Doesn't matter. Test data can stay at the end. I'm not really interested in that. That's all going to get wiped out. There we go, we've got a function that's a glue int. Load shader, and that's a const. No, it's just a char star. No, it's not, it's a const char star shader. Shader name. There we go. Because we've put it after, we have to declare it. Order matters in C. Where we're doing declarations. Here we go. I'll keep them in the same order then. There we go. That's all done. Should really keep a space between that lot, because that's going to get deleted. So we now have something called load shader. Doesn't do much at the moment, but let's see what we can do with it. So let's just check what our sandbox is doing here. Alright, that's okay. It's not modifying the file in any way. Alright, that's fine then. I can make a const char star actually I don't really need to do I can just make a char star. And this will be, let's call this one vertex shader. It's going to be a buffer equals read a text file, and for this we just need a file. And the file name is going to be a resources glsl plus shader name plus .vs. I think that's correct. Oh. Okay. Is it because of the constness? Will there be a change to shader name if I do that operation? Yeah. No. That's a .2. Interesting. That's not a string. That's just a bunch of bytes. I knew there'd be a problem here. Just didn't know what the problem would be. I've just realised what the problem is. Hey, where you gone? Come over here. We need a command. And std lib maybe. No, I think it's string .h. No, it's not. Standard lib. No. Well, okay, it's not in standard IO. To lower to upper. There's no toString. Type is size T. Turns a point to the first occurrence of a character in a C string. Great. Ah. Ew. Scanf. That brings back a memory. Scanf is... I think we might be using scanf to create a string. Reads data from... no good to me. There are different vscanf. Okay. Okay. No. Let's just go to speed dial. C programming. How to concatenate strings. String copy. And using child stars. That's fantastic. String copy it is then. There we go. So file. Got you. We want a file path. We want it of type. Oh. Oops. I want it of type char. And it's we'll have a 64 bytes. Alright, next, where is string copy? What's the include? It'll be strings, won't it? There it is. That's what we're doing. So it's a char star string copy, destination, const char star source. Okay. Well, let's do this one bit at a time then. File path equals string.h, please. We should really have stdlib as well to support other stuff, but anyway, string .h, please. Thank you. And file path equals string cpy copy, yeah. And it's file path, comma, whatever we want. So in this case, we want that bit. Okay, what's wrong with you? It's a char star. Must be a modifiable. That doesn't make sense. That's going to be a segmentation error, isn't it? If it's not making sense, it probably isn't. Oh, I see. Right. That's the way to do it in C++. Stop thinking C++. There's an interesting idea. str copy into file path, comma. Now we want our shader name. And I'm damn sure I have to put something in here. I don't trust it not doing it properly. No, it doesn't like it. That's it. Thank you. String copy, file path, and then we just want the last little bit, don't we? .vs. Yeah, things in C aren't as straightforward sometimes, because you've got to go back to the original code rather than anything else. That should be right. That makes sense to me. I like that one. So that is the vertex shader. There we go. Fantastic. And of course we will want a fragment. And that's fragment. And I'm going to put data at the end of that. There we go. No. Source. Because that's what it is. It's a source file. All it is a chunk of bytes that we're going to be reading in now. So how is that done? We just use whatever's in here. Read a text file, char star file, const char star file. Okay. Should have looked at that better. Gives back a buffer. So char star vertex buffer equals sand read a text file. We just need a text file, so that is... Oh, we've done that. Dar. Stupid me. I've already got that. Okay, so we've got a fragment shader. We've got all of the text files at this point. Let's find out if we have. And then I'll clean it up. It will be %s, comma, vertex shader source, vertex shader source, and I'll just surround that with return carriage. Sorry, new line N stands for. I better say that, otherwise people will get a bit iffy about it. %s, comma. I'm just testing now to see whether we are going to get the source or not. I want to know what we get. Just make sure there's no printouts already included. I think we took them all out, didn't we? Yes, we did. Good. Flow shader, color shader. Okay, let's have a look at what we printed out, shall we? We printed out null and null. Okay. Nothing in debug. No return statement. Oops. Okay. It's correct. There is no return statement. Just return 0 for a minute or two. They're not strings. We were able to print them out as files before, but now we've passed them back, we can't. Sounds a bit dodgy. Next, all I did was printf. Buffer equals %s. Okay. Thank you. Let's see what it does. Nothing. Why did it do nothing? Because I didn't compile it. Library, please compile. Thank you. Try again. I'm not getting anything. I'm not even getting errors. File in. File in is 46 according to this. But it's only getting .vs. Right, so why weren't we getting an error? Oh, it returns null. So it's just coming to there and returning null. Const char star file. Alright, fair enough. Let's get it working first before we start getting the failures. Stuff that. Stuff that. Stuff that. Because that's causing us a problem. We'll change you. Let's do a simpler method, shall we? Change you. And under run. Change you. Okay, everything matches up now. Good. Resources / glsl / whatever I called it. Color. Just take all the variables out and make sure your program works at the basic level before you start trying to do tricky things. C will bite you. Right, so we're going to place you in directly this time. Just test that out, make sure it's getting it. Thank you. Resources, GLSL. Right, we've got the right one. Step over. Right, what's in buffer, please? Yep. We have success. Can we just take that breakpoint out now? I'll do the print buffers here first, just to make sure. Don't know why I closed it. Oh well. Here we go, and we can now see that we do have our shaders. Or do we? Yeah, we do. There's a second one. Fantastic, we've got both shaders. That's good news. Means that we can work with them. Get rid of that. Save. And put the library back to normal. Thank you. We should get exactly the same program, except without the little bit in the middle. Okay, looking good. Yeah, I'm happy. Are you happy? I'm very happy. And I haven't even said hello to you all. I just dived into this. I am sometimes very, very useless. Right, we do have our sources for our shaders. Yum yum. What kind of sauce would you like? Tomato sauce? Chili sauce? Or me just being stupid? What do we do with them? what we normally do with them. We have to compile them. Right, so load shader. We need to compile them. So we need a program to do that with, which is a gluint. GLUint. Shader program. We're just about to create another memory leak on the graphics card. GL create shader, please. It needs a type? No, it doesn't. Just get on with it. Surely not. Shader type. Oh. Whoops. We're not creating a shader, I want to create a program. Whoops. Program. That's the one. Right there. Thank you. Right, so how do we create a shader? We need to do this stuff here. Create the shader. So, yeah. Shader source, yeah, we've got that. GL shader source, shader. Well, that's a program. Right, got you. So we need this one. That one there. That's the OpenGL command we need next. So what does that actually say? That's a source. Vertex shader. And we will have a fragment shader. GL vertex shader. And this one is, believe it or not, a GL fragment shader. Okay. I'm liking it so far. So that's two more things we're going to have as a memory leak. Great stuff. Actually, we don't need to. We can delete these at the end. But the shader program. Yeah, that'll be a memory leak. Good stuff. Because we need to keep that. Or a copy of it anyway. So at least we can return something now. Have we got a program yet? Yep, shader program. So, I don't know if you lot have ever built shaders before, but this is the most simplistic way of building a shader. By all means, don't do this at the office, shall we say. What I'm about to write is not commercial standard. It's development throw it at the wall standard. In other words, I'm not going to do any error checking. Which for shaders you must do. Otherwise you won't know what the hell's going on in there. Right, so our return value is not 0 anymore. It is something. What's that? Lovely. Right, well, we've actually got our shader code. We've got it off. We've got our source code. Now we just need to compile it. We compile and then link, I think. Or do we link and then compile? Right, I think we do this one. So we do this for both. So GL source shader, put the shader in. Where does the program go? Shader source goes in here. So it's this line and this line. These two lines are next, and then we've got the shader. Okay. So what do we got? What is it on about? Isn't that an enum? No, shader type is the enum. Gotcha. It's what we created. So it's vertex shader. We only want one doing. We need the shader source. Which is that. And we need the shader source length? Isn't that just size of? I don't think we get text.length. We're in C. But I'm going to look. Do we get a length? String length. So it's str length. Okay. Good. strlen. Open brackets, close brackets. Okay, const glint. It does return a star, doesn't it? Ooh. No. Leave it alone. Why would it want a star there? Why the hell do you want a star there? Because it's normally held within. Ah. Oh, that's great. Alright, let's pop the U there. Got to do it properly, otherwise this doesn't work. So... yeah. I can reuse a variable. Shader source length. Shader source length 0 equals that. That shouldn't be a problem. Do we pass it in as 0 or not? No, just shader source. Oh, Christ. Okay. That's correct, because that is a pointer. The name is a pointer of any array, even if it's only a size 1. Wow. So GL shader source is defined. And compiled. Yeah. Yeah. And we do exactly the same for the fragment shader. Fragment shader, where's the source? There. And there. Oh, that's the same. I'm gonna leave that alone. Yeah. We now need to attach those shaders. So that's loading a shader. I've already done that. Create the shader. We're supposed to check for errors. Oh well. Alright. So we create our two shaders, we've done that. We now need to bind the attributes. No, we don't. Because we already know where they are. We specified within our shader where they were. Where did you attach them? Ah, here we go. GL shader attach. That's the next bit. I'm glad I got that bit right. So it's that is program ID. And well, shader, isn't it? Whatever we've got here, compiled. Okay. Then we want our fragment shader. We can actually do the attach after that, make it all together. That would make more sense. put that there. And to put that there. Now we have our shaders attached to our shader program. We can do the final step. They are both compiled, we just need to link it all together, which is glink. And that's the last bit, isn't it? Don't think we have to do anything after that. Oh yeah, I know it's awkward here, but hey ho. Ah, validate it. Excellent. We have done it. Right, it's the validation at the end that I want to do. I'm not bothered about this error. Right, how do we validate? I bet I haven't said it, have I? There it is. Check shader error. We don't have check shader error. Who has check shader error? Start, stop, load, load, bind, create shader, load shader. Here we go. This is why I was skipping them. We'll think about that later. Right, that should return a shader of the appropriate type. Now we have our data in a VAO. And we have a shader. It's possibly the worst way you can ever try and build a shader, but that is literally a skeleton of what we need. We do need that check error thingy adding to it. We need another thingy here to check errors, which we will do. But I want to get it working first. So that returns your shader, a color shader in this case. GL use program, and it's just going to be color shader. That's it. Maybe not. Did we need to bind anything? First thing to check is, do we get a shader? Yes, we do. Is the answer? Because I knew it was going to be 1. we supposed to do our colour shader before or after? I usually do it first. That could be an error. We are using Vec4s as well, aren't we? Yes, we are. I want to try something. I just want to try something that I haven't done in years. Is it capitals? No, it's not. It's GL frag color. Let's just try an F5 on that and see if we still get it. Yeah, we do. Okay, continue. Oh. I'm going to have to do that, aren't I? You see what I mean? There's no way of debugging it. Everything's done on the graphics card. It's attach link and validate. Sorry, attach link, compile and validate. No, got it wrong in my head. Just got it wrong in my head in the wrong order. Alright, can we stop printing this rubbish out now, please? Pointless. It ain't gonna tell us now. I mean, even if I step through this, is it going to do any good? Shader program 0. Right, that should change right now. Yep, goes to a 1. We create the program, okay. Vertex shader becomes 2. Fragment shader becomes 3. Well, everything's correct so far. Shader source 182. Sounds about right. Compile shader. Don't know if it compiles. Got no idea if it attaches. Goes to 84, which is correct. Okay, compile. Attach, don't know. Link, don't know. Shader Pro, don't know. Everything looks right, actually. That looks correct. Got a sneaking suspicion. Got a sneaking suspicion. Yeah. Do we enable these? Yeah, we enable them. Problem is, there's no shader at that point. Might be useful if there was. There's no way it can do that. Order matters in C. Nope. I've used shader start and yes, I remember. Use shader start and shader stop. And that will be under. Let's look at the static shader. Static shader. We should have start and stop on here. No, haven't bothered. Interesting. Did I bother on here? Yeah. No, I didn't get anything wrong. What I really should do is zero it out after use as well. Okay. It's not doing it right, so there's an error somewhere. Taking vec3, vec2, yeah. Send through that instead of the colour. Yeah, already done that. Layout location 0 out vec4 colour. That's an interesting way of doing it. It's correct. Okay. But it's not the way I'd do it. Actually, no, don't put as many spaces in. No need to. Let's try that then. So terminal, rebuild, run build task. On the library in case I've changed too much. Nope, doesn't look as though I did. Nah. Right, there was that thing in the middle that I skipped. Maybe I shouldn't. Bind attributes. In here, that will be a virtual function, won't it? Override this to set the attribute list, yeah. So you'll find it in here, bind attributes. It's plural, be careful. There's 2 of them. And that has to go before linking. Which takes you back to here in bind attribute. singular. GL bind attribute location. That's the command. Glad I know how to program in C++. God. I'm not doing that before I'm linking, am I? What the hell's attribute? It's a glue int. That's its number. 0. This has to be exact. That's probably what I've done wrong, actually. I haven't checked through that I've done it correctly. Position. Okay, and colour. I've just assumed that I've done it correctly. Oh dear. I'm a muppet at times. That's why I called me cat Muppet. It acts like me. Ah dear. That's going to be colour. Now, when I did these attributes down here, yeah. There's no bind here. I set the pointers, that's all. Why do I feel as though I'm missing something? Because it doesn't work, yeah. Probably, yeah. It doesn't crash either. It should do. Okay, let's write an error function. The error function is a standard one, and we will find it in here, at the bottom usually. Check shader error. Okay. So it'd be void. Shader error. We need the shader, the flag, program, sorry, bool is program, and standard string goes to const char star message. Alright, we're okay. We can do this. He says. Alright, so we're going to have to convert this over from C++. That's fine. We'll do that then. It's exactly the same functionality. So that's okay. If is program, GL get program IV, yep, shader, flag, success, yes. Else. Let's do it properly. So I'm just neatening this up. I'm not actually changing the functionality or anything, because it's correct. Alright. Let's bring you back, check you out. I've changed one thing, and it is going to bite, to say the least. So if program, yeah, else. STD Sierra, no. That's printf. And it's just going to be error messages of %s. Error message. I've got this colon thing, which goes in there, comma, error, and we can get rid of the last bit, because that's just close that. What does error equal? GL char. So that's %s. There we go. And be polite, we'll put \n at the end. Right. We have that. I changed error message. That's the only place it's used. Should work. Does that compile? Before I change it all. Run build task. No. Right, let's go back to the beginning of that. A function definition is not allowed here before the thingy. What? What are you on? Did I mess my brackets up? Don't think I did. Else. Yes, I messed my brackets up. Close, open, close, open, close. May as well finish this off now. Started it. Let's do that. And close. Thank you. Let's try again. Compiles. Okay. No. Right, well, we know it's not equal to 0 because we checked it. Dun, 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 dun. Check shader error after the compile. GL compile shader, okay. We should also do one after the linking. So after the compile. So there. We want this new thing, which we can't use, by the way, because it's below. There we go. Declare. Alright, let's do it. Check shader. Error. The shader is the vertex shader. GL compile status, yep. False, yep. Error. GL compile shader failed. Yeah, I'm happy with that. Shows how close to C really is. The commands are basically the same, it's just the structure of the language is completely dopey at times. Pop it in here. And this is fragment shader. Okay. Hit F5. There we go. Unknown preprocessor direction. Oh gosh, there you go. Spelling mistake. As soon as you put an error checker in, it's easy to find. Got it correct in that one. There we go. That was all it was. We have colour. Isn't that lovely? Which means I can turn this awful red off. Now we have our first shader. So, as I said, you can't debug shader code. You have to write a function to do it for you. And we got that as well. So let's clean all this rubbish up. Alright, start at the top. What have we got? We should do the other check as well, really. you should also do one here. That's why that false is there, because that's the shader programs. It'll be true if it is a shader program. It's false if it's just the part, like a fragment or a part of a shader, like the vertex. So that's why there's a true or false in there. That's what we're looking for. That gives us the type of shader that it is, either a program, which is true, or a vertex or fragment shade, which is false, if it isn't a program. The error there is just whatever we want to tell ourselves. Not sure we need this now. Did we need it? Did we need that? No. We don't. Just to make sure, do a recompile. Terminal. Run build task. Sandbox. Yep, that's a rebuild. That's not a rebuild. And we still get the colour. Good. I'm still suspicious. CD projects. Sandbox. It doesn't know which one. Okay. And it will be build. There we go. There's our make file. Make clean. Done. 5. There we go. Had to rebuild itself from scratch. So yeah, we are good to go. Okay. Yes, I double check everything, sorry. I am not committing this mess. Okay. Run. Who's doing the GL clear colour? You are. Right, we want a GL clear colour. Actually, that might be 2.5%. I'll put that at 5 then. 0.5%. No. Let's take this at 5. 2, 5, 5. Okay. Try that for a colour. Okay, press F5, see what we get as a colour. A little bit too black, maybe. Yeah. That's definitely enough blue. Brighten it up slightly by 1%. Alright, we'll take it up to 7.5% blue. And we'll have that at 4.5% and that at 2.5%. That'll brighten it up slightly. That should be not black. Okay. I'm happy now. It's hard to tell on my screen whether that's black or not. Don't like it. Too dangerous. Black is the worst colour to have. That's also a very bad place to do a clear colour. I have to keep recompiling the library just to change the clear colour. No thanks. It can go in run. It can go there. Right. Red. Well, let's go with 10% red. 6% green and 2%. That'll give us a weird colour. Yeah, that's not black. I can tell now. Good. We have a background colour. Fantastic. Right, let's get all this text sorted out. That's okay. That's okay. That's alright. Here we go. Start here. I can't read it when it's all bunched up like this. So I didn't bother trying to go through it all, because I knew that it worked. I've written the damn code often enough. I should know when it works and when it doesn't. This is so much easier to read when you do it this way. I might put notes on this one as well. I'll do that off stream. I don't think you want to see me writing notes all day, do you? Oh, dunno, could do. There we go. Yeah, it takes up more space. Well, unfortunately, I do seem to have quite a lot of space to fill, so I ain't bothered. We used to be bothered, that's why, because our page lengths were maximised. Nowadays, doesn't matter much. They always used to say, never build a file more than 1,000 lines long or something. They had a limit on the file size. Because it slowed down the computer if you didn't. These days, computers don't care. They don't care about your file size. Just slowed down the compilation. That's all they were bothered about, the compile time. The funny thing is, if your compile time's over 10 seconds, then you have built it wrong. As you've seen, I am not really having problems with compile time. Up here, don't sit there, move. Come on. No, you're not sitting on the keyboard, come on. Either sit on me or sit somewhere else. We're not having that. I'm not playing that silly game again where you start typing with your backside. Good boy. Oh, bless. No, we don't need to bind. Didn't think we did. Did in the old days. After, I think it's about version 3 of OpenGL where the binding gets taken out. People just kept to the old way of doing it. So you see a lot of people doing it. I just test it and find out whether you need to or not. And if you don't, I don't. That's the way I program. Right, that's better. Alright, we've got problems here, obviously. That's a bit bunched up on that one. A bit more space required. Give it a bit more space. If you feel it needs more space, give it more space. There we go. This is when I usually do my review as I go through, so I'm actually reading this back to myself as I go through, as well as spacing it out, making sure everything's correct. And so far it has been. Looks good. This has actually turned out to be, I don't need to space that one out. Not size off. Do what makes sense. Yeah, that looks okay. Some decent programming done already today. So we have a successful shader implementation now for our game. I haven't even decided on what the game is. Shall we make a roguelike? That looks good. That looks a lot better. Let's make a roguelike. Stuff it. Let's at least make a rogue, and we'll call it Sand, because I'm doing a sandbox. Messing about. Here we go. Let's make a shader. Done. Now our colour's working. Ah, fixed memory leaks. That's next up. Let's It's called rogue underscore like the sand. Let's make it into a game. Rogue like the sand. Okay. Fix memory leaks. Where should we start? Oh, by going down all the memory and fixing the memory leaks, I suppose. Right. Don't need this. Ah, wait a minute, let's commit. Sandbox lib, what we got here? I'm just going to put incorporates shaders. Done. Wasn't hard. Oh, cancel. Hit the wrong button. Oh. There we go. Done. Not bad. I think I've earned a coffee. A cup of coffee. I'm just going to go and get a coffee. I haven't even said hi to you all, have I? Let's say hi to you all. I'm going to grab a coffee. Okay. Can't do it on this keyboard. Need a different keyboard. That does it. That's alright. Why do I have a 2000 error on my stream manager? You absolute plonker. Twitch, will you stop doing that? So, we now have shader building. We can have shaders. This is how easy it is to develop a game. It really isn't hard. Am I going to put that in the library? Yeah, I think so. We'll do that at the start tomorrow on the refactor. We can start with refactoring tomorrow. I'm not doing refactoring today. I want to fix everything first to make sure that my memory leaks aren't going to cause us problems down the line. Because at the moment, everything that we are doing on the graphics card, which is shaders and even that square, when we exit the program, they are still on the graphics card. We haven't deleted any of it. Not clever. I'll run out of graphics card memory soon. Like in about 100 years, the amount of memory that I'm using, but as this program grows, that leak gets bigger. So I'll go make a cup of coffee and then we'll plug the leaks. Grab a coffee if you're just joining me. Okay, let's plug our memory leaks. And welcome to my viewers who've joined us today. Good. So I've finally named it. It's going to be called Roguelike the Sand. Very descriptive name. Doesn't do much yet. Right, let's plug some memory leaks. Where have we got some? Right, we have a cleanup that we need to implement. So let's set that up. That's fine. Load shader. Ah, yeah. Right, load shader. What happens at that brace there? We're going to use the shader program. We don't need the fragment shader and the... so there's a memory leak. And the shader source. Or are they going to die? Nope, we've got hanging pointers. No, they'll die. They'll die. It's only program that won't die. So yeah, we need to delete the shader program. We can do that from here. Alright. No, we can't. We'll have to do it here. Clean up. Open GL. Which means anything stored on the graphics card. We'll have to do it when we come out of this main loop. Test square data. That's fine. Oh, that's already before the loop. That's fine. So we have to delete the color shader. Okay. Alright, so GL delete. Program. And that's just going to be our color shader, isn't it? Yeah. We now also need to go through all of our VAOs that we have created. So we have to delete all VAOs. that have been created. And we have to also delete all vertex buffer objects that we have created. Yeah, we should be all right with that. Now that means we need to record them. Which is why I spent all yesterday working out how to do vectors. And we need that before we run. So we will need VAOs. So this is a global. VAOs. So that will be global VAOs. We will also need why is sand a problem? No, that is correct. Do I need to inline these? Static. Explicit type oh. Interesting. Does this give a return value? No. And we also need VBOs. We might have to put this inside something, because it's not going to work. We can put it inside something and send it in as a reference. that's allowable. Alright, so we would need to check to send those in to our test data as addresses. Yeah. So that would have to become address they're no longer global as well, which is even better, I suppose. VAOs, VBOs, yeah. Address of VAOs and the address of VBOs. That's what I want to happen. Right, test square, you have to change. To sand vectors. Sand. Vector. And I'll call it it's going to be a pointer to the VAO storage. And again, sand vector pointer to the VBO store. Alright, that looks good. It wouldn't even work nearly. We have a program function up here. There we go. Lovely. I'm happy now. Now, VAO storage needs to be used when we create the VAO. We generate it here. And we bind it here. So every time we use gen, we need to store it. So that's VAO underscore storage. No, it's not. It's going to be vector underscore nothing. Append, yes. I'll do. Storage goes in. It wants the address. Well, I've got a pointer. And the integer is VAOID. Excellent. Like that. Yep, that'll work. We have to do the same for all the VBOs, or vertex buffer objects. Okay, we gen a buffer there. So this will be VBO storage, and it will be index buffer. You can see why I wanted vectors, because when we have a few of these. GL gem buffer. This is VBO storage, vertex buffer. It is a vertex buffer, isn't it? Yeah, it's a gen buffer, isn't it? Yeah, that's okay. Yeah. Bind. Yep. Whoa, we've got another one. I will have to note all of this lot up. I can't leave it blank like this. It's starting to become meaningless. We need the colour buffer, please. Pop you in. That's it. That's all we need to do. Yep. We need to test this. Right. On exit. We haven't done the... yeah, we've done the program, haven't we? Yeah. Yeah. This looks right. Let's go for it. Okay. It's no hiccups whilst we're making this lot. How about destroying it? Fantastic. The VAOs we have 1, which is correct, and VBOs we have 3, which is correct. we can delete them. Fantastic. And how do we do that? We know the size. So, 4. Got to be careful now. Should be a uint. Doesn't matter. Int index equals 0. Whilst index is less than vector underscore size, which it doesn't pick up for some reason, and VAOs. Then we can index plus plus. That's the number I want there. So it will be GL delete. Do I need a special one for a vertex array? Yeah, we do. Delete vertex array. GL size n. And then it wants the star array. I don't think that's a star. Can you get out of the way a minute? Yeah, thank you. Copy. That looks bad. Yeah. Right, what's up with it? I. Right, that's better. Sand vector or info. Argument type int is incompatible with the parameter of star gluint. Right, we have to take this first, don't we? So what I want is a GLUint. We'll call it VAO now, doesn't matter. VAO equals. Had this problem before. Easy one to solve. Nothing's really hard around here. And VAO. There you go. Just have to put a semicolon, I think, after that might help. And there we go. That's your deleter. Let's do our deleter here. And VBO's index. It isn't just delete, no. That's wrong. There we go. That's better. GL delete buffers, just one at a time please, and we'll delete the VBO. Nice. Let's see if we crash. Let's see if we crash the graphics card. That'll be even better. Nope, it works. Double check. Num shaders, GL detach. Ah, you're detaching them, aren't you? Do we really need to do that? I don't think so. We used to have to do that, but we've already discarded the shaders. We haven't though, have we? No. God, that's an old way of doing things. You don't have to do that. I'm not doing it. I think we're okay. That should delete everything, the whole program. We don't have anything else left. If we're detaching and deleting there. God, that's old school. That's 25 years old, that statement. I'm happy. Nope. On my code review, I'll probably look into it a bit more actually. I'm going to do the next code review on this. But right now, I'm happy with what we've done to plug the holes. Reclaim some memory. I'm going to keep the printf though. That's useful. But I will come back to this. I mean, I haven't even started doing the notes on all of these files. So I'm way behind on the work, but yeah. But I'm more happy with that than I was before. So I've deleted shaders, have we? Yep. Deleted the shaders. We've deleted the object off the graphics card. Can't think of anything else. VAOs, VPOs. Done. That was easy. All done. Graphics card should be clean on exit. Fantastic. Cup of coffee. Well done. It also means it's in the run, not in here. Which in my mind is a lot better. It's not in main. Okay. Cleanup performed on shader program, comma, VAOs and VBOs. And everything disappears. Come back to me. Nice. Right, I'm a lot more comfortable with what we've done. So, roguelikes. We need tiles. Now, do we need to load tiles? Or can I make that into a tile? Nope, because to view tiles you need a camera. If you want to view this in 3D, I can't move. Got no WAS or anything. I can't look at this from any direction. Camera. Oh, sneezing cat. Thank you, Muppet. Muppet. I wish you wouldn't shake your head whilst you're doing that. Never mind. Right, I'm just having a shower of cat fluids. It's amazing. It's amazing the way he does it. Absolutely amazing. Okay. Create a 3D camera that is capable of free movement. So free move is what we want to create, but we are going to need a camera. Let's make a camera. What's it going to need? Position, X, position, Y. These are not C++. Position, How's about Z? Then it's going to need rotation X, rotation. Can you tell that I've done cameras before? Rotation Z. And it's going to be perspective. All of these are floats. Now, I have two ways of storing these. I can store them as floats, which is probably the best way, I think, because now I can do something. How many floats have we got now? We've got 1, 2, 3, 4, 5, 6, and we're just about to add another 16. So that will be 22. We could have another 10 divided by 4. Could have another 2 floats if we want them. Right, what we'll do then is we will pack it. I'm going to use a GLM VEC3. VEC3. Global up. Or do I want to make it local up? Don't know. Map 4. That one. That's going to be perspective matrix. Okay. Yeah. I think I nearly like that. I could make these 2 VEC3s. I'm just wondering how many problems that's going to cause us down the line. Because these are important. Let's risk it for a biscuit. Why not? And my keyboard is doing nothing. Thank you, keyboard. It went to sleep. That really should be a quaternion. Fair enough. It's all you need for a camera. All you have to do is fill in each one of those. Yeah, that's great. How do you do that? Don't forget your semicolon. Right. So we can make a camera now. I think I'm going to start doing that as well. Oh, okay. There we go. Good. Funny thing is, our camera never needs to come out of here. We've got our shader. We've got our test data. There you go, we've got a camera. Alright, I don't want to move it. Rotation. Camera. Global up. And what else we got there? Perspective. Is that the last one we need? Bet it is. Position, rotation, global up, perspective matrix. Great. I want a GLM mat 4. Damn it. Just realised something. You only need to do that. I forgot. I have no idea how I'm going to do this. Oh god, I've got a manual, have I? Go back to JLM. This is what we're building here, the camera. They've actually got it here for me. Okay. Projection. I've named it wrong. What will people think if I start naming things wrong? So they've already given me the first part there, haven't they? And they call it perspective. Oh god, I hate people. That's the idea, is that we do that. Pi float blah de blah times 0.25. Oh my god, is this in radians? No, it's 9/5 because that's what I did for my screen. That's your aspect ratio. Near plane, far plane. So, aspect ratio. This is the angle, 45 degrees. Pi float over 0.25. Pi over 1 is 180 degrees divided by 4. It's 45 degrees. It's in radians. That's a ball ache. That's 45 degrees in radians. Pi over 2 is 360. Pi over 1 is 180 degrees. So pi over a quarter is 45 degrees. Nice. So that's great fun. This is your aspect ratio. Our screen is 900 by 500. So all I haven't done is put the zeros in. There you go, 900 by 500. Gives you an idea. This is the near plane, which is 10 centimeters in front of your face, or from the camera. And the far plane we are setting at 50 meters away from us. That's the furthest that any graphics will draw. That's your far plane. Okay. There we go, we've got a camera. All we have to do now is camera dot projection matrix equals projection, which I did wrong. Get off me. So we now have all the bits we need for a camera. That's all the code there is. Not bad, huh? Why am I marking this code? Because it ain't gonna stay in here. Alright, so that's how you set up a camera. We can now use that projection matrix. What else have you got in here? What other tricks have you got? I'm not translating it and I'm not rotating it. View equals that, 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 and that. I'm not doing that at this point. Oh. I want to move it though. Wonder why they're only doing that model bit for scale. You only do translate and rotate for a camera. For a model, you'd have to do all of them. But we are going to need a view. Okay. We are going to need a view matrix. We could hold the view matrix in the camera. I will think on that one, but we are going to need one anyway. So let's make one. Oops. Do a space there, might help. Do a space there. Let's find out what's wrong with this. Don't want that as a capital. No capitals, please. That's an M. That's a view underscore matrix. I want to make sense of what they've put first. The model matrix is separate. Why the heck they've only put... Oh, right, okay. I think I know what they're doing. The model matrix is where that rectangle is on screen. That's for your model. So that's linked to this test data. So that's where the test data is going to be. So that really should be test data model matrix. Right, starting to make sense of this now. Good. Let's see what they've done. They have scaled it. By 1. Why have they got a map 4 in the middle of this? Right, okay. So what we have here... Why are you scaling it like that? It's... The model matrix is translation, rotation, scale. Ah, right. I'm not sure I like what they've done, but yeah, it's translation, rotation, and then scale has gone completely wild at the bottom. Fine. Let's have a look what they've done in here. That's camera position. Yeah, they're using a float. That's just, oops, minus. Camera dot position. Close. Alright, what's this next one? Rotate view. Underscore matrix. Rotation of Y. What did they have Y as? GLM vec2, okay. So they're rotating around the Y-axis. So what I want is camera dot global up dot y. No, that's not right. They're trying to do the rotation around the x-axis. No, z-axis first. Right, that is camera dot rotation dot z, comma. That doesn't make sense. So why have they got it around the x-axis? You rotate x around the y-axis, do you? Never done that before. Done the translation. Doesn't matter which way around we do the x. That's correct. This is now you can see why I break these down so much. Rotation. View matrix, yeah. We will have now oops. Camera dot rotation, and we'll have y around that direction. Yeah, this is great stuff. I love doing these things. I'm going to check these though. By the way, if you want to know, this is the first time I've ever used GLM, which is why I'm looking it up. I'm also going to double check everything. I don't think this is right, put it that way. It would be z-axis. I don't like the way they're doing this. According to that, we've got all the projections. Test build. As you can see currently, our square is not exactly square. It's been stretched out because of the way the screen is. I've put this in widescreen, like a normal TV. Same size, same dimensions as a normal TV, which is 9x5 for a widescreen, which stretches our square. I want to make that into a square. So it should really be a square about here in the center. Chop, just squish it in a bit. That's all I'm asking for. We could try it. We could try it. I'm willing to try it. We have our shader, don't we? It's GL get uniform location. That's the one we want. And then we have to send in the values that we want. Shader, 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 shader. Load of floats, here you go. Right, so that's how you would load them in. We should have these matrices here. I think it's going to be GL false. Alright. Those are the commands that we are going to be running, and we will be running them after we use program. So V. So we're going to need 3 locations. The locations will be, I think it's just a GL int again. Yeah, it is. So I want 3 GL ints. So we want GL int, and it will be model matrix location. We'll want a GL int view matrix location, and we'll want a GL int. The last one was projection, was it? Yeah, projection. We'll call it projection. Projection matrix. If you want any of this explaining, please ask in channel or put it in the comments below if you're viewing this on YouTube, and I will go through anything that anybody wants. I don't mind. We just have to find those locations. Well, there aren't any, is the answer. Those locations don't exist. What we are going to do is this. Uniform. Map 4s. Do I have to put in? Don't know. But map 4. We'll find out. What we're going to have is model matrix. Uniform map 4. This is going to be the view matrix. And uniform map 4. projection matrix. We have to find them because there's no location given for a uniform. So we actually have to look them up. And that's usually best stored into a variable, which we've done. So save you out. And they have to be exact. All of these names have to be exact when we do the lookup. So that's what we've just entered into our shader. Okay. So it's equals GL get uniform location, which takes the program and a GL char star name. Well, the program is our color shader. That's easy enough. So that's color shader, comma, and this is where it becomes important that we do it exactly the same. Otherwise, for God's sake, stop popping up things on me. There we go. That's it. So it's color shader, comma, and the next one is view matrix. Well, no, if it works, it'll go square. GL get uniform location. Stupid to say, isn't it? But yeah, that's how I measure my successes. Things on the screen that go square. That didn't sound right to me. Didn't sound family friendly. Okay, those are our locations. That's the first one. That's the second one. And that's the third one. What are they doing here? And matrix gobbledygook. I decided on GL false, didn't I? It just changes the rows, how the rows and columns, which one comes first. That's all it does. I don't want it to change. So OpenGL is in column major order. I think GL matrix is column major as well. Let's bloody hope it is. Right, so let's get our model matrix. Pop it in to model matrix. Yeah. No. That's the way I used to do it. And it's happy, so I'll do it that way. All it is a two-dimensional array. 4x4 array is a matrix. Okay. Let's take whatever we've cocked up and put in here. Let's go and find out what that looks like. In here. There we go. Should be happy with that one. Last error is projection. There we go. Does that release the errors? We all ask ourselves. It does. It seems to be happy with it. We haven't used them, by the way. So it is projection matrix times view matrix times model matrix times position. Crash, come on, crash. Well, we did something. That's exactly what I expected. Interesting. Where should we start? Right, well, we've got the shader done anyway. That's fine. All we need now is to get all these bloody numbers right. Let's do the math. Woohoo! Math time. I love this part. So we've got some kind of weirdo setup that they gave us online for this. I would prefer an online interactive manual. Ah, wait a minute, this one looks alright. It does have quaternions. Fantastic. We'll have some fun with this then. Got an FAQ. That hurts my eyes. Well, this is great. It just gives a load of frigging pictures. Yay. Isn't this what we need? Yeah, I don't like what this is doing. What's GLM load matrix? Why is it in blue and I can't click on it? Ah. Float angle, axis. Right, so I'm doing angle axis on my rotations. Good. That's nice to know. But I clicked on transform. And you're telling me about rotations. Ah, here we go. That's what I want. Right, I can do the calculations properly now. These are the actual things that I need. So how are you doing it? You are going on the constants. Okay, you're just putting a constant. I don't know what a D means. So I don't care about that. Right. Okay. We have what we need. That is for certain. Alright, it's not shaders anymore that we need. It's matrix multiplication and maths. Fantastic. Ah, bless. Render engine. It will be... I bet it's in draw entity. Prepare instance, here we go. Right. So from our entity, maybe we should create an entity at long last. That might be interesting. With a position, a rotation and a scale. And a global up, of course, I suppose. Well, that's global, so I already know what it is. It's a y-axis. And then all you do is load it up to the shader. So I can calculate it and load it up to the shader. Right. We need that when we're drawing it, though. This is the draw cycle. The preparation of the instance. This should be done first, after the shader has been activated. Right. That makes this slightly different. What I'm going to do is keep that. I think this part's right. I can check it. Goddamn check it. All I have to do is that, and I'll know if it's right or not. Okay. Yeah. 0, 2 and 1. That's fine. It's working. Fantastic. So that's working. It has to be 0, 1 and 2. It doesn't matter which order it's in. I don't really care about the order. Depends what order I type them in, I suppose. It's just as long as we can get them in there at the correct locations. Looking good. No, Muppet, you'll have to move it. No, Muppet, you'll have to move it the other way. Come on. Thank you. God damn it, you've sneezed all over everything. Oh, Muppet. Thank you. It's lovely. Oh, bless. Do love him though. I think he's ace. He does look after me. He tells me when it's food time. Right, so how do I want to do this? I want to make a function for each one. Yeah. Let's keep them all separate in their own separate functions. No, don't jump up on me, Muppet. Thank you. Now you can jump up on me. It's perfectly alright. Come on if you want now. It's okay now. Yeah. So, decisions to make. We'll get the locations, that's fine. This stuff here is just rubbish. Yeah. It's rubbish. I don't like it. I don't like it one little bit. I prefer to put my own stuff in. Yeah, just get rid of the lot. It just looks like trash to me. There we go. That's better. Don't need those lines in anymore. They can go. Right. Okay, we're getting somewhere. It might look as though I've just deleted a load of programming, but I haven't. It was just example rubbish that they gave that just, I don't think is anywhere close to what we need. I think I want it here. I want a map for, what do we need? Model view and camera projection. Model. I'll just put them in as that, I think. You're purring very loudly. Yes, you are. I've also got something wrong. I got something so wrong it's stupid. That's view matrix. It's not projection at all. Projection's from your TV. You have to project onto the screen. The screen is a projection. The camera is the view, and the model has to be positioned as well. Correct. Thank you. Got it right now. Thank God for that. Right. So we want camera. I'm going to do it down here first until we get a picture, I think. Camera.view. Matrix. We have to set that. And we should have preset the one that I thought we were doing, which was the view matrix. We're not changing the size of our... We haven't got a resize function. Oh, okay. Something to think about. We make our model, we've got our shader. We can still take that view matrix, can't we? Projection matrix. We can make that before we go in here. We can make our projection matrix here. So that's where that goes. This is probably the easiest one to do. God knows what those what that means. Right. We want the angle. Pi. Divided by 0.25 f. Comma is what they used. Um, 9.0 f divided by 5.0f my aspect ratio. Z near 0.1f, 10 centimeters, and 50.0f. Z far. Why doesn't it like GLM pi? Yeah. Am I missing something again? Probably. I could do GLM radians 4.50. Oh. Muppets. Muppets, Muppets, Muppets. Okay, we'll do that. Uh, 45.0f. Thank you. That gives us a projection matrix, which I'm happy about. What else is static currently? Our view is static, so we should pre-declare our camera matrix. That's where we went wrong. All right. We should pre-declare the camera view matrix before entering. Right, so that takes the calculation out. So that can be cut out of here. And we can do it pre with this. Okay. Let's call it calc camera view matrix. Looks good to me. I think that's what we should do. That'll separate it off and let me concentrate on just the camera view matrix. What are you up to then? Okay, cat's okay. Right, let's do it. Let's make this a thing. Let's make it a real thing. Right, so we have done shaders. Now we're into matrices. Right, so that becomes a GLM map4. That becomes what it is. That'll do me. Let's create a function. I put it below the shaders, didn't I? Here we go. Right. So I want GLM colon map4 result. Is that how we do it? Seriously? It's a legal statement, but I like it about as much as I can throw it in the bin. That's how they're doing it. Fine. Okay. How to create a camera matrix. It's simple. Terrain, static. Have we not got a maths here? Yes, we do. Good. Oh, got me dice. Toolbox, it's in here. That's creation of a model matrix, creation of a view matrix for a camera. Here we go. So what we are going to be doing is that lot. There. And then we just return the result. Right, okay. Let's close this down. This is fun, this is fun. Got to convert all of this into GLM. Fine. I will do that. So we just want 3 rotates and a translate. It's rotate, oh, sorry, rotate. Does it give an answer or not? Source, angle, axis. Alright, which way round is it? Alright, so it is equal to. Okay. That's the first thing I needed to know. It's operating on rotate X, Y, or Z. Why the X, Y, and Z? I don't understand that. Why are they rotating it around the opposite thing? That just doesn't seem right to me. Yeah, that's right. Pitch, yaw, and roll. X, Y, Z. Two radians, yeah, okay. won't matter because it'll be 0. So we just need to do that rotation. That's going to be interesting. Could really do with this. I'll stick this on screen as a basic identity for what they're doing. Then we'll change it. Alrighty. That's your basic identity. Result equals GLM rotate result by camera X, please. Ah, we don't have it. Doesn't matter. Yeah, we'll pop you in. That's you done. Take that breakpoint off that I've left lying around. There we go, that's everything done. Okay. Camera dot rotation dot X. That's now correct. What's wrong? No instance of overloaded function GLM rotate matches the argument list. Argument types are map4 error type. What? Navec 3. That's a float. Have I missed a comma? No. I've missed a 2 radians. God, do I have to get past all this rubbish again? Yeah. Yeah, load identity, yep, done that. Rotate a map4 floating angle. Doesn't say whether it's in degrees or radians. And a vec3 constant on the axis. And it gives back a GLM map4. Yeah, I've done it right. Skunk, skunk, skunk. So map4, cam rotation X on the X axis. I think I need that GLM2 radians here. Radians. Why are you trying to go forwards, Muppet? it's camera rotation. Yep. I think I'm happy with that. Alright, so we have to do that 3 times. And it's minus here. Interesting. I didn't know that was possible. Right, so we rotate 3 times. So that's your rotations done. I want to do X, Y, and Z, which means, why did they put -1 in? Oh, yeah, I know why. Makes another part of your program slightly different when you come to move them and rotate them. That's what that's about. 0, 0, 0. I prefer it in the other part of the program, thank you. I'll control my rotations from the mouse. Alright, so we've got a translation now. How would you like to do a translation today? I'd like to do it like this. Use the manual. Right, we have result. We can copy to here. Muppet's acting strangely. I'm a bit worried. Muppet, are you okay? Are you with us? Muppet? Okay. Interesting. It's usually about this time when he starts fading out like this. I think he's going unconscious. Muppet? What's wrong? Are you still with us? Are you still with us, love? You're getting awfully floppy. Can you wake up? Can you wake up, or are you... No? You're not waking up fully, are you? You're only half waking up. Are you aware of your surroundings? Yeah? Yeah, you are. Okay. Alright, I'll just cuddle you here. No? You can move. Good. Right. Let's get you moved. Come on. Let's get you moved, love. Alright. You okay? Just that you were passing out, love. Are you aware of what's around you now? Yeah? Okay. He's still very hot though. Be careful. Yes, he was. He was starting to pass out there. Okay. Whoops. Got to keep an eye on this cat. This cold is a killer. I don't really like this COVID nonsense. This is camera translation, camera position. Yeah. Where's the negative? It's minus camera position. Okay. Thank you. Control V, I was about to say. It's not result. It's camera dot position, and it's negative. Yep. Okay, that's good. Any errors? Nope. I think it is as simple as that, but will that work? Yeah, should do. The negative is because we are viewing through the camera onto the scene. So the scene is in the opposite direction to what we're looking. That's why you have something called a stage left and a stage right, I suppose. Right, calculate camera view matrix seems to be doing its job. I'll pass that one. Alright, let's get back up into the fun. So, what we got left? Model matrix. We've got a static scene. The model will not be moving. Good. Right. Yeah. Calc. The model matrix. I think that's the best way of putting it. What do I call it in here anyway? Oh, create model matrix. Yeah, okay. Calc model matrix. Right, what am I going to do for this? It really should take in the model. Really. But we haven't got an entity to pass it. Okay. We're not doing an entity system just yet. That's the next stage. There we go, let's declare it and start from there. Yeah, that'll be fine. We're not really going to calculate it, we're just going to pretend to, I think. There we go. And it's going to start the same as the other one. GLM map4 result, and that's the 1 point identity matrix is what I'm asking for there. Nothing on there. Okay. Return result. So I'm in the same boat with this, but at least I've got an idea of what I'm doing now. Fine. What we are doing is that. And you'll notice that the order is different because it's forwards instead of backwards. That's the backwards way of doing it. This is the forwards way of doing it. Right, where we haven't got numbers, I'm just going to put in a vector. So it's a translation. I'm just going to put in zeros, aren't I? So that's the first one. Except it's going to be translation to nowhere. Vec, can't do it that way. GLM, Vec3. And it's 0.0f, 0.0f, 0.0f. That's the done. The next three are the same rotations as before. I wonder if I should do ZYX. Never thought of that before. Why not? Let's reverse them. So we'll take you. And let's make you into something that's useful for us. Result, radians of 0.0f around the x-axis. Yep, looks good to me. No rotation at all. Really what I'm doing is I'm just stubbing this out. I'm not really that bothered. Yet. So we're rotating 0 around the x. Yes folks, I'm actually doing a 0 rotation. That will change. All of these Vec3, these radians will be supplied by the entity. But at the moment, I don't want any of that at all. The last should be the scale. Yeah, it is. Which we don't have. Okay. It's that one there. There we go. Copy. And we're not scaling it by anything. So there's your constant, or whatever. And the factors are 1.0f. Multiply anything, any size by 1 and it will stay the same. That's just a multiplication thing. That. There we go, done. Happy. So that's false thing there. That should do it. No, it doesn't. Ah. Yes, it does. Helps if I put the model in front of the camera, doesn't it? Where have I put the model? Oh, nope. Yeah, put them at 0. And the closest we can see is 0.1. How's about putting it at -1? That's a safe place to put it. -1. Put it at that. Yep, that helped. It's a square. Done. Thank you. I usually put things at -3, but hey ho, who cares? Let's try to... I want to try and gauge how big that square is. I think we're right, it's 1 meter across. It should now be half the screen to the edge. Yes, that's correct. So it's now gone from being a squashed square to a proper square using matrix calculation and a shader. This now means that we should be able to move the camera, because we are calculating the camera view with the negative camera position. I wonder if this will work. Oops. Shall we see if we can try and move the camera? Okay, I'm gonna save this now. MVP matrix now in place with a static camera. Ta-da! Who says programming is hard? Muppet did just then. So we have a camera. Can we move our camera? The answer is yes, we can. How hard is it to do? Bloody easy, actually. Because we already have it in place. Somebody thought ahead whilst writing this stuff out. And it's here in the while loop, while running. We are already checking for the escape key, are we? Yeah. Quit. Yeah, well, checking for that X button at the top right hand corner, not the escape key. How do we do SDL keyboard? SDL keyboard events. It's been that long I can't bloody remember. But it's an event type equals an SDL keyboard event, I think. Most people would then use a switch. Can do. Switch on which key was depressed. Switches aren't allowed multiples. No, I'm not using a switch then. I'm using an if-else statement. And I need 2 of them, so you can have 2 keys at once pressed down. So you can go diagonally. Yeah. Go back to the top. I think we've done our camera. So that's bits done. think movement is better. That's better. That's where we're up to. Give the camera movement. It's funny because we're going to give the camera movement now, and when we come to program the game after all the testing, we'll take the camera movement away and make it a fixed camera looking at the player. That's going to be an interesting day. As we're going to use right mouse button held down for movement, I think. Yeah. We can calculate a movement speed from the character statistics. Our avatar, which we haven't got yet. Yeah. My god, this sounds easy. Give the camera movement, let's do that. I have no idea how to do this. It's been that bloody long. I know roughly how to do it, but... This is getting a bit big again, isn't it? Is this... Oh no, this is run. That's fine. Run can get as big as it wants, I can just stop using it and do another. That's where we are. Christ, how many lines of code is this now? Do you think this file's getting big enough yet? I haven't even split those ones down, those long lines. You can tell that I haven't done it yet. I think I should do that. Actually, yes, I will do that. We'll keep everything properly done, I think. I don't want to start messing up my file now. I might publish this. And if I publish it, I would like it to be properly readable. What Muppet? So we'll do a little bit of this, I think. I'm glad I know how to do this. If I'm making it all look too easy, just let me know. I think I am. I'm going to enjoy refactoring this. I really am. Because that's what we have to do next. We can't leave it like this. I mean, these files are becoming massive. Right, what have we got up at the top that's massive? Ah, I missed something. I don't need to set up camera doing, do I? No, I don't. Gosh. Cleaning up code. Code cleaning. At least it gives me a look at what I've done wrong and right. There we go. That's better. These ones I can't really help too much. Okay, we're right down here now. I am thinking of leaving that one in. What looks better? I'll leave it like that for now. I might decide against it later. If I can't read it later, then I will change it. I might change it on the final one anyway. At least the code's cleaning up nicely. I'll give it that. Oh, food? Right, yeah. That's a good point. I think I'll order some food tonight. I didn't bother last night. I think I should eat something today. Might help. Going to see my wife on Thursday. I am actually looking forward to that. I am now, anyway. We're still on lockdown, but we've been given permission to go and see her. That's very kind of them. Make for a nice change. Right, that's a lot better now. What have we got here that's lumpy? Test data, that's fine. Right, everything's working. What are we on? 1604? I think that is a final. A finish. A finito. We are on that line there. Fantastic. Well, you never know. This game might come along, because once I've got this in position, it's easy. It's easy. I just make a load of tiles out of our test data. I'll rewrite our test data to be a tile. That would be a good idea. Yeah, I'll look at that. So, I would like to say a thank you to everybody who's popped by today. I hope my C programming is not completely dysfunctional to you. Tomorrow, I may have done this by tomorrow. Just put this keyboard thing in, because it's only a small piece. It's just like, if such and such key is depressed, check the events. If the key's been pressed, then move the camera, because we have camera position, so we can. We have camera position X, and I think I'll use camera position Z. We'll do up and down as well on Q and E, So Q will be up, E will be down. So our W forwards, A strafe left, D strafe right, S go backwards, Q and E up and down, and I will need the mouse for rotations, rotating around. Actually, I'll probably do that one first. So, actually, if we use the mouse right button to rotate, I can't use that for movement. Oh, I can later on because it's a fixed camera. So I might, no, I'll do keyboard events only. I'll do arrow keys for rotation. Yeah. So WASD for normal movement. And I will use arrow keys for rotation because I need the right shift key, the right mouse button being free until we've ended our testing, and then this lock just gets taken out. So as it's a deletable, I should really do that. To be honest. There we go. Alright, that's where we're up to. Fantastic. I'd like to thank you all for stopping by. I'm just going to go and I'm a bit worried about my cat actually, so I'm going to take the cat downstairs and make sure it's on a cold floor. So we can lie down on a cold floor and reduce his temperature. And in the meantime, I would like you all to have fun, relax, chill out, and stay safe. Now, how do I stop this again? Found stop. Got it. Stop button. There we go.